Research on FuelDynamics helps managers describe live and dead fuels that burn during wildfires. This provides improved information about fuels, including their patterns of change over space and time.
Fuel mastication is a way of treating fuels. It's just like mashing with your teeth. You chunk up the pieces of wood and you'll lay all those chunks on the ground. The benefits of this is to reduce the fuel quantity in the air. There's a lot of different ways that fuels are masticated. And what they do is they put different types of cutting heads on different machinery. A rotating head, a horizontal head, a mower, and a chipper. You can chop it up and you can burn it, or you can just chop it up and lay it on the ground. What we've discovered is the aging process is really fairly slow in the Rocky Mountains. I'm looking at the chemistry of those particles and trying to see how the chemistry has changed. After 10 years, there's a little bit of change that I can say. We don't have anything that's quite old enough to give us a really definitive, okay, this is what happens when they're old. This project has had a lot of different people who have worked as part of this Joint Fire Sciences project.
The mountain pine beetle is a native beetle, lives by attacking trees, laying its eggs under the bark. When the eggs hatch, the larvae eat the inner bark of the tree. When trees are healthy and there's not too many beetles, trees can often successfully defend against the beetle attack with sap. When there's drought or too many beetles, the beetles can kill the tree. This causes the pine needles to dry out, losing moisture and changing their chemical content. These changes increase the flammability of the pine needles, making them burn faster and more intensely. The Rocky Mountain Research Station and our partners are working hard to identify just how the beetle affects fuel changes and how those changes relate to fire behavior.
Live fuels are very dynamic. They change a lot season to season and from species to species. Live fuel moisture is a quantification of how much water is in a plant relative to that plant's dry weight. Generally, with a dead fuel, we quantify the dead fuel moisture the same way. Throughout the season, the only thing that changes in a dead fuel is how much water that fuel soaks up or gives off to the atmosphere. With living plants, they actually have mechanisms to constrain or to change basically how much water they lose at any given moment. It's those dynamic things that we're really studying to try to capture how that particular leaf or needle ignites and then how it burns after it ignites.
StandFire is a new computer system for modeling forest fuels and fire in 3D. StandFire builds on the models that we've had for projecting forest growth over time and connects them to 3D physics-based fire models. The objectives of StandFire are to develop a new prototype system for modeling fuels and fire, to provide us with new ways of thinking about fuel treatments, and to build a platform for collaborative research for fire science advancement. We need computer fire models to help us understand how forest changes translate to fire changes. In the past, the models that we've had have not really described forests with adequate detail, making it difficult for us to understand just how much a thinning or a prescribed fire will change future fire behavior.
For more information, please visit the Fire Fuel and Smoke Science program at www.firelab.org.